Hello everyone and good morning. Today in the class we are going to discuss mock paper. So it is basically your fourth mock and first we will be starting with paper 1. So I have simply selected some questions that we will be solving. Okay. Chalo, let's get started. How many of you did the very first question? This was a simple question, I would say. From the rolling, if you're getting such sort of question, even in second paper, there were questions from rolling. Done it? So I just included one over here. And both the questions were from the basic of rolling. If you know how to write equations in rolling, then I mean, it was quite easier in that case to do. Okay, so we will solve this question. Question ye tha, there is a uniform solid sphere of radius r and that is spin with angular velocity omega and placed at a corner wall as shown in the figure. Okay, so it is in contact with two surfaces. If the coefficient of friction at the wall as well as flow is mu, then number of turns after which the sphere stops. Okay, so it is not from rolling, I remember. Yeah, it's simply the question ki you have a solid sphere which is rotating with certain angular velocity omega. You are keeping in touch with two friction containing surfaces and you are getting asked after what amount of after how many number of turns of rotation the sphere will stop. Okay, so in is initial omega naught ka value is given, that is equal to omega. Now the moment you will place it on these two surfaces, what will happen? What is going to happen the moment you are going to place this sphere on the surface? So see here, it is in contact with this point, it is in contact with this point. The moment you will place it over there, this point has tendency to go down like this, and this point has tendency to go forward like this. Okay, and friction will just oppose this tendency, and hence friction here will be, I will say, F1, and friction here will be how much? It will be F2. So F1 and F2 frictions are acting like this. Now what else are the forces acting? So here normal reaction N1 and here normal reaction N2, and then there will be mg force like this. So if you draw the FED of this, there is friction force, not in this sense. There is a friction force like this, that is your F1, and then there is your friction force like this. This is your F2, this is your N2, and this is your N1, and then this is your mg. How we can go around it? बोलो, क्या करना चाहिए था हमें? You know what are the the forces acting, right? What now we need to do? If you look here carefully, हमें करना ये चाहिए कि we need to calculate torque. ठीक है, क्योंकि if it is stopping finally, then I mean retarding torque is acting, and if you know the torque, you can calculate alpha. ठीक है, and if you know alpha, you can simply put in the formula omega square is equal to omega naught ka square plus 2 alpha theta. If you know theta, you can say how many number of turns are there. I mean, if there is, this is 2 pi, the number of turn is 1. Accordingly, we can calculate theta. So the task is to calculate tau. Tau कैसे निकाला जाए बताओ? So if you see here carefully, there is this basically this solid sphere is simply rotating with angular velocity omega. Nothing else is given here regarding it will roll or something like that. Okay, so we will go that way. If you see here, this F2, this F2 will get balanced with mg because there is no motion in the vertical direction. So F2 equal to, I will write as what? mg. Okay, sorry, F2 plus n1. F2 plus n1. Let's write all this thing. सारे इक्वेशन को ध्यान से लिख डालो. So F2 plus N1 is equal to how much? It is mg. This is first equation. Also in the horizontal direction, we need to balance because nothing is getting talked about the velocity, right? So let's do here one thing. In the horizontal sense, this is N2 and this is equal to how much? F1. So N2 is equal to how much? F1. Now let's talk about the torque. Torque acting around its center of mass. So if you calculate torque acting around its center of mass, through center of mass, what are the forces acting? कौन कौन से फोर्स है जो सेंटर ऑफ मास के थ्रू जा रहे? सो डेफिनेटली mg is passing through center of mass, n1 is passing through center of mass, n2 is also passing through center of mass, f1 and f2 are not passing through center of mass. If you calculate its torque, this is this and this is this, both are in the same direction. So net torque is f1 plus f2 ka r, that is radius, and this is equal to I alpha. ठीक है, this is equal to I alpha. The moment you will place it on the ground, you will get such sort of equation. So I have written all. Now you just need to solve it. Now how we can solve it, बताओ. F1 को हम क्या लिख सकते हैं? F1 को लिख सकते हैं म्यू एन. F2 को क्या लिख सकते हैं? F2 को लिख सकते हैं म्यू एन टू. And this is equal to how much? R I alpha. Now N2 को क्या लिख सकते हैं? F1 लिख सकते हैं again. और F1 को हम क्या लिख सकते हैं? म्यू N1. So basically यहाँ पे N2 को what we can write? In place of N2 we can write mu N1. So this is your mu N1 plus mu N2. N2 is what? Mu N1. So mu square N1, and this is R is equal to I alpha. Now N1 is equal to how much? It is equal to mg minus f2. एक सेकेंड, इसको सही से सॉल्व करो. n1 को क्या लिख सकते हो? mg माइनस f2. f2 इज हाउ मच? म्यू n2. n2 इज हाउ मच? म्यू n1. सो यहाँ से पुट करना पड़ेगा माइनस म्यू n2 को क्या रखूं बताओ. ओके, n2 इज म्यू n1, सो दिस इज म्यू स्क्वायर n1. इसको इधर लेकर जाओगे तो n1 हमारा क्या बच रहा है? n1 is equal to 1 plus mu square is equal to mg. So n1 is equal to basically mg by 1 plus mu का square. This is what we are getting, right? So can you see the calculation now? I mean you can do it now. जैसे यहाँ पे हमें torque का equation मिल गया, f1 plus f2. We have these three equations. So you just solve it wisely. I won't just complicate it by getting stuck with the calculation. So if f1 plus f2 into r is equal to how much? I alpha. I का value already know. That is 2 by 5 mr square. And here this is what? n2 is equal to f1. So n2 का value तुम put करोगे f1, which is equal to mu n1. This is another equation. f1 को आप क्या लिखोगे? mu n1. f2 को क्या लिखोगे? mu n2. These are equations that we can use, and also there is one more equation. This is this. Okay, use this equation, solve it, you will be getting the answer. Okay, so concept was this easy. It was not difficult. You just needed to put in the values. किसी को doubt है concept में तो बताओ, or anything you want out of me, then let me.
No, ma'am.
ठीक है ना, चलो ठीक है, फिर आगे बढ़ते हैं, है ना. How many of you tried this question? There is here electricity shortage from long time. There was some sort of a storm, so it's very difficult in hot weather. Yes, how many of you did this question? Anyone? Anyone tried it? देखो, जेई एडवांस के क्वेश्चन में क्या होता है ना, यू नीड टू टेक अ स्टेप. आई एम टेलिंग यू दिस. व्हेन यू टेक स्टेप यू स्टार्टेड गेटिंग क्लोजर. जैसे वो होता है ना, हेज में देखते हो जो ठंड के टाइम में जो फॉग होता है, you start moving towards, scene starts getting clear. So जेई एडवांस के क्वेश्चन देखकर लगता है कि क्या करे, समझ में नहीं आता. जो भी समझ में आया है करने की कोशिश करो. मे बी यू विल गेट द आंसर. आई एम नॉट 100% श्योर, बट मे बी यू कैन गेट. So question here was, there is a steel ball bearing, and this bounces vertically on a steel plate. So there is a steel plate, and on this there is a ball falling like this. If the speed of ball just before bounce is vi, so just before the collision speed is given, and that is given as how much? Vi. It must be in the downward direction. Okay, the speed of ball immediately after is alpha vi. So immediately after the collision, its velocity is become alpha vi. ठीक है, alpha is less than 1. So overall you can say its speed is decreasing with time. Which one of the following graph best shows the time of successive bounces as a function of time t? देखो, अ, हमें ना टर्म्स को क्लियरली यहाँ पे पढ़ना था. दिस इज टॉकिंग, टाउ इज व्हाट, टाइम बिटवीन सक्सेसिव बाउंसेस, एंड दिस इज ओवरऑल टाइम. ठीक है, सो दिस विल बी बेसिकली द टाइम ऑफ सक्सेसिव बाउंसेस. कहने का मतलब कि व्हाट टाइम इट इज टेकिंग इन कमिंग डाउन एंड देन गोइंग अप, दैट विल बी द टाइम ऑफ सक्सेसिव बाउंसेस, राइट? क्योंकि एक बार जब ये यहाँ पे कोलाइड किया है, लेट्स से एट t इक्वल टू 0, अगेन व्हेन इट विल कोलाइड, व्हेन इट विल गो अप एंड देन कम डाउन, सो ओवरऑल कंप्लीट साइकिल, राइट? So tau is basically talking about the time between successive bounces. How you will calculate this time? तो देखो, calculation को we should make more easier. Time period का formula you know, projectile का 2u sin theta by g, and this is a case of plane projectile where theta is equal to 90 degree, because this theta is what angle that initial velocity is making with the horizontal, and here it is 90 degree. So this is equal to how much? 2u by g. ठीक है, so if you talk about first time when it will, I mean again it will bounce, then how you will calculate it? I mean, और nth bounce का टाइम निकाल लेते हैं, n को जनरलाइज करते हैं. so let's say tau n I'm talking about, this is time between successive collision at the nth collision. ठीक है, so if you write it here, you will write 2 by g velocity at velocity final at I mean velocity at nth collision. Let's write it like this. So अगर आप ऐसे लिखते हो, you will write it like 2 by g. vn को आप क्या लिखोगे? अल्फा vi, and what will be the vi? Vi here is what? Velocity at n minus 1th collision. How you will write this alpha, this vi? So if you talk here about this, suppose कर लो, when it is just hitting the surface, let's say its velocity is vi for the first time, then its velocity, or let's generalize it more. Let's say कि एक सेकेंड, एक काम करती हूँ. Let's talk about this कि when it is just colliding first time, then its speed is u. Then after second collision, its speed will become how much? U alpha. In third collision, it will become how much? U alpha ka square. In third collision, it will become how much? U alpha ka cube. You can see like this, है ना? क्योंकि VF is written as alpha VI. And for the first collision, if we talk about, then this will be equal to alpha V. That is alpha U, right? फर्स्ट कोलिजन कहने का मतलब कि एक बार टच करने के बाद जब दूसरी बार वो टच करेगा, so this is alpha times it will keep on increasing. So if I'm talking about tau n, I can write here 2 by g alpha n vi. I can talk like this, है ना? So this is time between successive collision at nth position. ठीक है, now we have to talk about this as a function of time. So tau as a tau versus t का ग्राफ बनाना है. अब tau और t को कैसे रिलेट करोगे? दिस इज द क्वेश्चन. अब इसको ब्रॉड पिक्चर में आप देखो, बॉल ऐसे गिरा, इट वेंट अवे लाइक दिस, अगेन इट केम डाउन लाइक दिस, अगेन इट वेंट अवे लाइक दिस. सो बिटवीन दिस एंड दिस, how much time elapsed? It is 1, I mean it is the time between successive collision, tau naught, tau 1 ले लो, यहाँ पे क्या हो जाएगा? टाउ 2, यहाँ पे क्या हो जाएगा? टाउ 3, एंड सो ऑन, राइट? So time between successive collision, if you're going to add all this, you will get the time t. Finally, I mean, if I'm talking about here, it is nth time colliding at any random time t, then t can be written as what? T, tau 1 plus tau 2 plus tau 3, like that. So you simply were required to add this thing. आपको इसी को ऐड करना था, कुछ नहीं करना था. ठीक है, सो अगर आप टाइम निकालोगे तो टाइम को आप क्या लिखोगे? यू विल राइट इट लाइक 2/g को आप कांस्टेंट ले लो, क्योंकि एग्जैक्ट वैल्यू हमें निकालना नहीं है, वी हैव टू सिंपली ड्रॉ द ग्राफ. सो इफ यू आर गोइंग टू, vi को भी कॉमन ले लो. अब मैं यहाँ पे अल्फा प्लस अल्फा का स्क्वायर प्लस अल्फा का क्यूब डॉट डॉट अप टू अल्फा एन आई विल डू. ठीक है. सो इफ आई डू इट, t/g, वी आई को मैंने एक कांस्टेंट वैल्यू लिया है, यू समझ लो. सो दिस विल बी हाउ मच, अल्फा को मैं बाहर ले लेती हूँ. Alpha is also a constant less than 1, and if it is less than 1, its addition will be 1 minus alpha n divided by 1 minus plus होता है, क्या है फॉर्मूला? Yes, it will be minus alpha, 1 minus alpha, right? So this is the formula. अब हमें किसके बीच का ग्राफ बनाना था? हमें बनाना था ग्राफ टाउ टाउ वर्सेस टी का. ठीक है. एंड टाउ इज टाइम बिटवीन सक्सेसिव कोलिजन. सो इफ यू सी हियर, ठीक है, चलो एक काम करो, अब फिर से इसको लिखो. टी इक्वल टू क्या लिखोगे आप? टी इक्वल टू लिखोगे 2/g वी आई अल्फा माइनस, अगेन यहाँ पे आप लिखो 2/g वी आई अल्फा एन प्लस वन समथिंग. ठीक है. एंड दिस इज डिवाइडेड बाय 1 प्लस 1 माइनस अल्फा. इसको मैं इधर लेकर आती हूँ. इफ यू लुक एट इट नाउ केयरफुली, आप इसको ध्यान से देखो. दिस इज लुकिंग लाइक व्हाट? 1 माइनस अल्फा t is equal to, this is a constant, right? vi alpha 2/g, this is a constant k. मैंने इसको k लिखा. and if you look at here carefully, vi into alpha n plus 1, this is what? ये क्या होगा बताओ? ये टाउ जैसा कुछ होगा या नहीं होगा? टाउ n को मैंने क्या लिखा था? 2/g अल्फा वी आई. ठीक है. सो अगर अगर तुम्हें टाउ एन लिखना है तो यहाँ पे वी एन होगा, राइट? एंड वी एन को अगर आप लिखोगे तो वी आई इंटू अल्फा एन प्लस वन, और अल्फा एन वी कैन राइट, लेट्स से. तो भी अल्फा कांस्टेंट ही बचेगा. सो हियर यू आर गोइंग टू गेट टाउ एन समथिंग विथ सम कांस्टेंट. ठीक है. So this is along the y-axis, and this time is along the x-axis, and this is your y-intercept in that case, right? So which one will be the graph? Graph is definitely going to be a straight line with negative slope. So it is this, right? क्योंकि यहाँ पे slope अगर आप ध्यान से देखो, sorry, you got finally what? Even if rough you are getting, na, it is fine because everything else is constant. You just have to take care of t and tau n. ठीक है. सो इफ आई राइट हियर 1 माइनस अल्फा t इक्वल टू k माइनस टाउ n. सो स्लोप हियर इज नेगेटिव, y इंटरसेप्ट इज पॉजिटिव, एंड देन दिस इज दिस, राइट? सो उसका ग्राफ कैसा दिखने वाला है? कुछ ऐसा ही दिखेगा, राइट? स्लोप नेगेटिव आना चाहिए. सो अगर तुम लोग एग्जैक्टली ना सॉल्व करके कुछ रैंडम ही करते, तो कुछ आइडिया लगता जाता कि चलो टाउ एन का क्या मतलब हो रहा है, और टाउ वर्सेस टी का ग्राफ बनाना है, तो टाउ एज ए फंक्शन ऑफ, आई मीन एनी रैंडम टाउ यू नीड टू राइट, है ना? सो दैट वी डिड हियर एंड वी
मैम,
गॉट द आंसर.
सक्सेसिव बाउंस और सक्सेसिव कोलिजन सेम है?
यस. यस, दोनों ही सेम है. बाउंस का मतलब क्या हुआ? बाउंस का मतलब ऊपर जा रहा है, ऊपर जा रहा है का मतलब कोलाइड करके जा रहा है, राइट? सो सक्सेसिव कोलिजन और
ओके
सक्सेसिव बाउंस. यस. सॉरी, आई कुडंट हियर यू.
ओके मैम, ओके मैम,
ओके ओके
आई
ओके
गॉट इट।
ओके. तुम लोग ऐसा क्वेश्चन बहुत किए होगे कोएफिशिएंट ऑफ रेस्टिट्यूशन से रिलेटेड. तो क्वेश्चन घूमता रहता है, आई वुड से. कितने लोगों ने इस क्वेश्चन को ट्राई किया था? देखो, अगर तुम लोगों को ग्रेविटी का याद है, यहाँ पे ग्रेविटेशनल फोर्स की बात नहीं थी, बट स्टिल ग्रेविटी में ना, आई ऑल्सो डिस्कस्ड इन वन क्वेश्चन. इफ यू आर गिवन टू मास, if you're given two mass, and if they are moving under the effect of their gravitational force, इसका क्या मतलब था? इसका सिंपल मतलब ये था कि if external acting is zero, if we are considering this capital M and small m as a system, if this is system, it means whatever gravitational force is acting, that is internal force, and that will not change its center of mass position. And that is why in such sort of questions, what we did is we talked about fixing its center of mass somewhere, and around this center of mass, this capital M mass will go round in a circle, and this small mass will also go round in a circle. ऐसा क्वेश्चन हमने किया है, ठीक है. सो यहाँ पे क्वेश्चन थोड़ा सा ट्विस्ट ये था कि देयर इज ए स्मॉल बिट ऑफ मास 4 kg, ठीक है. दिस इज थ्रेडेड ऑन ए स्मूथ यूनिफॉर्म रिंग, सो इट इज समहाउ हियर फिक्स्ड, ठीक है. दैट इज थ्रेडेड टू इट, आई मीन इट इज ऑन टू इट, ठीक है. एंड mass of ring is given as how much, 6 kg, and this was given as how much, 4 kg. Its radius is given as r is equal to 0.5 meter, ठीक है. Initially the system rates in a gravity free space, gravity free space है, so no question of gravitational force acting, we have to rule it out. And the bead is struck, bead is struck, I mean you are just giving it some impulse, ठीक है. It is struck again. कभी कभी मैं भी इस क्वेश्चन को जब पढ़ रही थी ना, तो आई वॉज रीडिंग अ स्टक, ठीक है. सो दैट वाज अ मिस्टेक आई वाज डूइंग एक्चुअली. स्टेटमेंट का बहुत इफेक्ट होता है. सो इट इज गेटिंग स्ट्रक, आई मीन यू आर जस्ट हिटिंग इट, यू आर गिविंग सम impulse to impart it a velocity of 5 meter per second along tangent to the ring as shown in figure. Choose the correct options, ठीक है. So it was talking about magnitude of force of interaction. जैसे ही तुम्हें ये देखा ना, यू शुड गेट अलार्म कि चलो ठीक है, ग्रेविटी का केस लगाते हैं. केस मतलब फोर्स नहीं, जैसा हमने वहां पढ़ा था उसको अप्लाई करके देखते. कैन बी डू इट हियर. सो फोर्स ऑफ इंटरएक्शन पूछ रहा है, यानी कि फोर्स एक्टिंग बिटवीन बीड एंड रिंग, राइट. बीड और रिंग के बीच का फोर्स पूछ रहा है. इसका क्या मतलब हुआ, इंटरनल फोर्स की बात कर रहा है. एंड बिकॉज ऑफ दैट इंटरनल फोर्स ओनली, जैसे यहाँ पे अगर आप देखो, ये एम मास है, दिस इज द सेंटर ऑफ रिंग. इफ यू टॉक अबाउट सेंटर ऑफ मास ऑफ द होल सिस्टम, it will be somewhere here. And if you consider this as center of mass, bead is here, bead is given velocity perpendicular to this thing. So it's looking like at this instant, it is traveling in a circle such that here the velocity is 5 meter per second. It seems like that, right? Here is the center of mass, here is the bead, and its velocity is like this. So if velocity is tangential to the trajectory here, we can say that at that instant it was in circular motion with center at its center of mass, because force responsible for this circular motion, or for this yes, for this circular motion is going to be the internal force of interaction between ring and bead. क्योंकि और कोई फोर्स नहीं लग रहा, ग्रेविटी को हमने रूल आउट कर दिया है. देयर इज नो अदर फोर्स एक्टिंग, राइट. सो व्हाट वी कैन डू, अब तुम्हें उसकी चिंता नहीं करनी कि फोर्स ऑफ इंटरेक्शन का नेचर क्या है. वी सिंपली हैव टू कैलकुलेट इट. सो लेट्स स्टार्ट डूइंग इट. हाउ वी कैन डू दिस. यहाँ पे बस ट्विस्ट ये था ना कि सेंटर ऑफ मास इज नॉट इन रेस्ट, सेंटर ऑफ मास इज मूविंग विथ कांस्टेंट स्पीड. कैसे, आप यहां से चले, क्योंकि इस केस में हमने यही देखा था, दोनों मास रेस्ट में थे. दे स्टार्टेड मूविंग अंडर द इफेक्ट ऑफ ग्रेविटेशनल फोर्स, सो सेंटर ऑफ मास इज एट रेस्ट, ठीक है. बट इन दिस केस व्हाट हैपेंड, वन बॉडी इज गिवन स्पीड इन दिस डायरेक्शन 5 meter per second. देयर इज सेंटर ऑफ मास, सॉरी, लेट्स फर्स्ट कैलकुलेट द सेंटर ऑफ मास. चलो पहले निकाल लेते हैं. सो यहां से अगर ये 4 है, ये 6 है, let's say it is here, then x cm, I'm just taking this point as the origin, then I can write it like 4 into 0 plus 6 into this distance is how much, is it given? Yes, that is given as 0.5. So यहाँ आप डाल दो 0.5 divided by 10. So this is going to be how much, 0.3 something, right? 0.3. So if this is 0.3, this is 0.5. Let's calculate the velocity of center of mass. This is equal to how much? 4 into 5 plus ring. At that point, ring is not moving. So it is 0 divided by mass of these two, that is 10. So this is 2. 2 in which direction? In the direction of 5 meter per second, because we have got positive value here. So center of mass speed is in this frame, is in this direction. ठीक है, how much? 2 meter per second. Now let's use this thing. Let's use it. So ये क्या कहता है कि if body is moving around center of mass, यानी कि for this calculation we have taken center of mass as the frame of reference, right? फ्रेम ऑफ रेफरेंस हमने किसको लिया था? सेंटर ऑफ मास. ठीक है. सो हियर ऑल्सो इफ यू टेक सेंटर ऑफ मास एज द फ्रेम ऑफ रेफरेंस, what will be the speed of this 4 kg particle? क्योंकि
Three,
we are
three.
talking, yes, that will become how much? 3 meter per second. So velocity of 4 kg particle with respect to center of mass is equal to velocity of 4 kg particle with respect to ground minus velocity of center of mass with respect to ground. So this is going to be equal to 5 minus 2, that is 3 meter per second. So it is moving in a circle with a speed 3 meter per second around this center of mass. Now you can easily calculate force of interaction. That will be mv force secant square by r1. That is mv square by r होता है ना? हाँ. 0.3 is equal to force of interaction. ठीक है. Let's put the values and see what we are getting. This is 4 into, this is 9. This is 3 into 10. This is force of interaction. So this is going to be how much? 120 Newton. So is this answer correct? Yes. This is wrong. Yes. The minimum kinetic energy की बात कर रहा है. अब देखो minimum kinetic energy क्या होगा? दिस मे साउंड कंफ्यूजिंग क्योंकि तुम लोग सोच रहे होगे कि स्पीड तो 2 मीटर, कितना आया बताओ, कितना आया था हमारा? 3 मीटर में 3 मीटर पर सेकेंड है, यूनिफॉर्मली जा रहा है. वाई इट्स स्पीड विल चेंज, एंड इफ इट्स स्पीड विल नॉट चेंज, देन वाई मिनिमम और मैक्सिमम काइनेटिक एनर्जी की बात हो रही है? सो वेन एवर यू कैलकुलेट काइनेटिक एनर्जी ऑफ एनी बॉडी, दैट इज एब्सोल्यूट एनर्जी. ठीक है. ये जैसे हमने रिलेटिव टर्म किसके लिए पढ़ा है? वी हैव talked about relativity when we talk about velocity, when we talk about displacement, but we never talk about relativity when we talk about kinetic energy. It is always absolute term, so always calculated with respect to ground. Done it? So when you are calculating kinetic energy, ठीक है, when you're calculating kinetic energy of the bead, then this velocity you have to write with respect to ground. Velocity of bead with respect to ground you have to write. अब देखो ground के respect में क्या इसकी velocity change होगी? Let's check here. So let's do the check. Just see, this bead is threaded here, right? And then there is this center. It will go in this circle. ऐसे जा रहा है ना, हम ऐसे imagine कर रहे हैं. Then, so with respect to center of mass, its speed here is how much? 3. As it will go reach here, जैसे ring ऐसे जब move करेगा, this bead will be here, its velocity is in this direction. Similarly, when it will, imaginary circle की मैं बात करती हूँ, अगर यहाँ पे bead होता है और यहाँ पे होता है, यहाँ पे होता है तो bead की स्पीड किधर होगी? इधर होगी 3 मीटर पर सेकेंड. And then speed of what? Speed of which thing? मिनिमम कहाँ होगा? मैं डायरेक्शन से जाती हूँ, चेक कर लो एक बार. यहाँ पे 3 है, यहाँ पे इधर 3 है, यहाँ पे इधर 3 है. विथ रिस्पेक्ट टू सेंटर ऑफ मास, इट्स वेलोसिटी इज लाइक दैट. सो वेलोसिटी ऑफ बीट विथ रिस्पेक्ट टू ग्राउंड आप कैसे निकालोगे? वेलोसिटी ऑफ बीट विथ रिस्पेक्ट टू सेंटर ऑफ मास, दिस इज योर वीबी माइनस वीसी. प्लस करेंगे या माइनस करेंगे? लेट्स चेक. वेलोसिटी ऑफ सेंटर ऑफ मास विथ रिस्पेक्ट टू ground. Yes, we will do the plus. So VB minus VC plus VCG. This we are going to do, right? And if we will do this, we will get what? We will get finally VB minus VG. So what will be the value? बताओ. हर्षिता, वॉइस लैग कर रहा है. ओके, क्या हो गया कनेक्शन को? But here it is showing fine. A lot. Is it for everybody? यहाँ तो कनेक्शन टॉप दिखा रहा है अभी. Is my voice lagging for everybody?
No, ma'am. Voice is clear.
अच्छा, हर्षिता, you are having problem on your side, I guess then. ठीक है. So if you have to calculate minimum kinetic energy, then what you need to do is, okay, हर्षिता, maybe So when it will be minimum, you simply need to add these two velocities, and when at which position you will be adding, then you will be getting the minimum value at this position, right? Here center of mass is in this direction, so that you will be writing here as plus 2 j cap, and this you will be writing as minus 3 j cap. If you're going to add these two, you will be getting minus 1 j cap. That is the velocity of bead with respect to ground at this instant, right? And here kinetic energy will be minimum half mv square. So half into 4 into 1 ka square, and that is going to give you 2. ठीक है हर्षिता, that's great. ठीक है, everyone got it? Clear है सभी को? Anyone any doubt in this?
मैम मिनिमम वेलोसिटी कैसे निकालेगा ये समझ नहीं आया मुझे सही से.
अच्छा ठीक है ठीक है, चलो मैं एक काम करती हूँ, लेट मी रिमूव एवरीथिंग फ्रॉम हियर. सो तुम्हें कैसा दिख रहा है? तुम्हें ऐसा कुछ दिख रहा है ना? This bead is threaded to the ring. I mean, it's not going to move with relative to the ring on the ring surface, right? It is threaded. So when the ring is moving in this sense, this bead is also moving, right? But just now we have seen for the bead, we made it go round in a circle with center at center of mass here. So for the circular motion of bead, I have drawn an imaginary circle. So let's draw the imaginary circle here. Bead is here. This is the center of mass of the system. Center of mass is moving in this direction. Bead is bead is going like this. So here the velocity of bead will be in this direction. Here it will be in this direction. Here it will be in this direction. Okay. So velocity of bead is going to be in different directions. अब तुम्हें ये बताना था कि when kinetic energy of bead will be minimum, so you have to tell when the velocity of bead with respect to ground is going to be minimum. क्योंकि जब भी kinetic energy आप निकालते हो ना, you take velocity with respect to ground always. There is no relative thing for that thing. ठीक है? So we always take velocity with respect to ground. So VBG will be minimum where? This velocity 3 meter per second, we have seen this is velocity of bead with respect to center of mass. So velocity of bead with respect to center of mass is how much? 3 unit. And at different instant, it is in different directions. It is directed differently at different positions. Okay? What is the velocity of center of mass with respect to ground? That is always 2 j cap. Okay? So if you have to calculate velocity of bead with respect to ground, what you will do here? You will simply add these two. So you are going to do VBC plus VCG. These two you are going to add. अब आप ये सोचो कि when you will be adding to get the minimum value. So when they will be oppositely oriented, right? So here bead will be oppositely oriented, that is downward. So here bead ka speed with respect to center of mass is minus 3 j cap. Velocity of center of mass with ground is 2 j cap. So overall velocity is minus 1 j cap. And hence kinetic energy minimum will be half 1. So that is 2 joule. Clear है?
Yes ma'am. Yes.
चलो ठीक है. Everyone did this question. This was easier one, I would say. You just need to have the concept. So everyone did this. देखो मैं बोल रही हूँ तुम लोगों को यूनिट एंड डायमेंशन का easily able to do it. So please don't leave it. Done है? कभी कभी क्या होता है ना, we are so much indulged in NLM and rotation and rolling that we forget this small and effective things. So please go through formulas, go through concepts, solve more questions from unit and dimension. Device thing. ठीक है, so वर्नियर कैलिपर था यहाँ पे, and you have to measure the length of pencil as shown in the figure. List count of my vernier scale is given. That is 0.05 times the value of one main scale division. first look at the main scale and look at this thing. So which is the portion of main scale is given? This is this, right? And if you look at vernier scale is not drawn here, portion of main scale is given. If you see here, main scale का list count क्या दिख रहा है? Clearly you can see 8 centimeter and 9 centimeter ka mark is given, and in between these two mark there is how many division? 10 division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So overall 10 division. So 1 centimeter is divided into 10 small portions, right? So one small portion will be equal to how much? 1 MSD, that is one small portion. One main scale division will be equal to 1 by 10 centimeter, and that is equal to 1 millimeter. So this is basically your centimeter scale, where list count is how much? 1 millimeter. So MSD we know. Now what is the VSD? VSD is also given in the question. List count of my vernier scale is 0.05 times the value of one division. So 1 VSD को आप यहाँ से लिख डालो 0.05 millimeter. This is given, right? Now what is the question? My vernier scale has n division. It has total how many division? N, and coincides with n minus 4 division of main scale. ठीक है? While measuring the length of pencil, n by 5th division of vernier scale exactly coincide with main scale. Now choose the correct option. आप कैसे निकालोगे बताओ? सो हमें निकालना क्या क्या है, पहले हम ये देखते हैं. लिस्ट काउंट हमसे पूछा गया है, एंड वी आर आस्क्ड द वैल्यू ऑफ एन. सो सबसे पहले चलो लिस्ट काउंट निकाल लेते हैं. लिस्ट काउंट क्या होता है? बहुत सिंपल है, MSD माइनस VSD. दिस इज व्हाट वी नो अबाउट लिस्ट काउंट. ठीक है, सो व्हाट विल बी द लिस्ट काउंट बताओ? मेन स्केल. ओके, लिस्ट काउंट ऑफ वर्नियर स्केल तो ये है, ये तो हमने ऑलरेडी निकाला, राइट? सो दिस इज करेक्ट, है ना? वर्नियर स्केल का लिस्ट काउंट क्या आने वाला है? 0.005. ओवरऑल हमसे नहीं पूछा गया है हियर. सो no, what I was going to do, no, this is not required because list count of vernier scale is already given in the question. That is 0.05 times the value of division of main scale, right? This formula we use when, ये हम तब यूज करते हैं ना, when VSD is known in terms of MSD, then we calculate it, right? But here it's already given. A list count of vernier scale is 0.05 times main scale division. So clearly we can write, I have written here, this is this, right? Now what is the thing given? My vernier scale has n division and coincides with n minus 4 division, and we have to calculate n. Okay, then we need to use this formula. Why? In order to calculate simply n. ठीक है, कैसे? देखो यहाँ पे हमें क्या दिया है? n division of vernier scale, that is n VSD is equal to how much? बताओ. coincides with n minus 4 MSD. सही लिख रही हूँ ना? मार्क देखते रहना, गलत नहीं जाए, ठीक है? So 1 VSD is equal to how much? n minus 4 by n MSD. ठीक है, लिस्ट काउंट हमें ऑलरेडी पता है क्वेश्चन में. लिस्ट काउंट ऑफ वर्नियर स्केल इज हाउ मच? 0.05 millimeter. So we already know this. Let's put the value here. 0.05 millimeter में लिख रही हूँ. मेन स्केल डिवीजन MSD लिखो यहाँ पे, माइनस वर्नियर स्केल डिवीजन, दिस इज इक्वल टू n minus 4 by n MSD. ठीक है, सो दिस इज इक्वल टू 0.05 is equal to n minus n, this is 4 by n MSD, and 1 MSD is equal to how much? 1 millimeter. So MSD को 1 कर दो आप, ये भी millimeter में है, ये भी millimeter में है, so we don't need to bother about the unit. So 1 and n is equal to how much? That is 4 by 0.05. So this will become how much? 80 something. क्या दिख रहा है? 80. So value of n we are getting as 80. It's not 40. So A will be wrong. It's not correct. ठीक है, simply. Now what else we are asked? Length of pencil. Reading कैसे लेते हैं ना? देखो मेन स्केल की रीडिंग तुम्हें दिया हुआ है, दिख रहा है डायग्राम में. कैसे पढ़ेंगे? I will show you. उसके बाद हमसे ये बोला है द पेंसिल द n/5th डिवीजन ऑफ वर्नियर स्केल एग्जैक्टली कोइंसाइड विथ मेन स्केल। रीडिंग ऑफ वर्नियर स्केल हम कैसे लिखते हैं? मेन स्केल रीडिंग प्लस वर्नियर स्केल रीडिंग, ठीक है? This is the net reading. Okay, what is the main scale reading here? Let's read the scale here. So अगर आप ध्यान से देखो, it is up to how much? 8 से यहाँ चलो 1 2 3 4. So ये वाला जो मार्क है ना पेंसिल का, it is lying between this 4 and 5. ठीक है? So up to 4 it is confirmed. It is 8.4 centimeter for sure. A little more than that, and that little more is how much is getting measured by your vernier scale. ठीक है? So main scale reading आप क्या लिखोगे यहाँ पे? 8.4. What will be the vernier scale reading? For that information is given. Information is that the n/5th division of vernier scale coincide with the main scale of when you are inserting pencil, or when you are trying to measure the length of pencil with respect to vernier scale, then this division is coinciding with main scale. Which division? n/5th. So n/5th into list count. This is how we write the vernier scale reading. Coinciding division into list count. So this is 8.4 plus n is how much? 80/5 into list count is how much? 0.05 in by 10 kar do, kyunki this we have written in centimeter. This should also be in centimeter. Now you can check it and you can get the answer. So this was the simplest one, I would say. If you know the concept, you would be able to do it. So you should know the concept. Please don't miss it. Screw gauge का भी इसलिए मैंने question include किया. Screw gauge में भी you should know कि positive error कब होता है, negative कब होता है. Questions इससे ज्यादा difficult नहीं आते हैं. So you should be solving such questions. How many of you did this? किसी को doubt है तो पूछो.
मैम इसमें n क्या था?
क्या क्या था?
n
n कहाँ है? अच्छा यहाँ है. हाँ, तो n क्या है पता नहीं, तो सॉल्व करके पता चलेगा ना क्या है. देखो क्वेश्चन क्या था. Let's solve it, then only we can get to know, right? A uniform rod of length L. This is rigidly attached with a uniform semicircular ring. Attachment is here. This is the ring, half ring of same density as of rod. So दोनों का density जिससे बना है that is same. The system is hanged in a vertical plane. So they are in vertical plane. ठीक है? This is important line. In equilibrium, again this is in equilibrium with the help of hinge. Hinge is here. It is applying forces in such a way that things are in equilibrium, such that rod is in horizontal position, and during equilibrium rod is in what? Horizontal position. Then the distance of center of mass of system from hinge is this. Find the value of alpha beta. ठीक है? So overall this system is in equilibrium. ये पूरा system तुम्हारा किसने दिया हुआ है? Equilibrium. और equilibrium का मतलब क्या होता है? Net force acting 0, net torque around center of mass 0. Always remember, when you are talking about calculating equilibrium, rotational equilibrium, always calculate torque around center of mass. So tau cm you have to make it equal to 0. ठीक है? और ये 0 कब होगा बताओ? बोलो. सपोज कर लो सिस्टम की हम बात कर रहे हैं ना. सो सपोज कर लो ये पूरे सिस्टम का सेंटर ऑफ मास कहीं यहाँ. लेट्स अज्यूम. ठीक है? सो इफ सेंटर ऑफ मास इज हियर and it is hinged at this point, so rotation if happens will happen around this hinged position, right? I am taking center of mass of system here. So overall total mass, let's say rod का mass m1 है, ring का mass m2 है. So m1 plus m2 g, and if you calculate torque around hinge now, because of this gravitational force there will be torque, and hence no equilibrium, right? क्योंकि whatever force is passing through hinge, because of that there won't be torque around this. No worries. We have to adjust the center of mass. Where we need to adjust it? We need to bring it somewhere on this line, on the line passing through the axis of hinge, this. So that when you calculate r cross f, this r also will become 0. Because if center of mass is, let's say, on this line, then mg will be in along this line, and this line of action of force is cutting the axis of rotation. It means net torque is going to be what? 0. Net torque is going to be what? 0. ठीक है. I told you to calculate tau CM, but here I calculated tau around hinge. Even if CM के around आप calculate करो ना, if CM is here, then around hinge, I mean इसके around अगर torque निकाल रहे हो तो hinge के forces का torque मिलेगा. So this center of mass and hinge का जो line है, that should line the same vertical line. ठीक है. So we have to make center of mass where, let me draw somewhere here. So this is the hinged position, and here this is this. This is the rod. Here this is this is hinge. So your center of mass should be somewhere here, let's say. So let's say through this point, this is the x-axis and this is your y-axis. ठीक है? How we can go around calculating this thing? अब आप एक काम करो. If I am assuming that center of mass is on y-axis, then xcm का value क्या होना चाहिए? 0. क्योंकि I have taken x-axis as this, y-axis as this. If y-axis is this and center of mass is on y-axis, it means xcm is 0. And what is the meaning of xcm equal to 0? xcm आप निकाल लो. इसका मास मैंने m1 लिया, इस रिंग का मास मैंने m2 लिया. अब आप ध्यान से देखो, इस रिंग का मास कहाँ, सेंटर ऑफ मास कहाँ होता है? इंडिविजुअली लेट्स टॉक अबाउट इट. इट इज इक्वल टू 2r by pi, right? This is 2r by pi, if I'm not wrong. And this will be at a distance somewhere here, L by 2 distance पे होगा, because it is of uniform mass, right? Just give me some time. There is some not network issues. I just need some time. Okay? Yes, let me know. XCM का वैल्यू क्या लिखोगे बताओ? What are you going to write it? XCM equal to what? बताओ कैसे लिखूं? So you will be writing, this is M1, this is M2. So you will write M1 X1. X1 किधर है? पॉजिटिव है. सॉरी, इसको M1 लिया है ना मैंने. So M1 minus L by 2 plus M2 into 2R by pi divided by M1 plus M2, and this whole will become 0 because this side this is 0, right? So M1 plus M2 तो चला गया. If you see here, you will get M1 L by 2 is equal to M2 2R by pi. From here we can get relation of L and R because R is not given in the question, right? M1 को आप क्या लिख सकते हो? Let's say linear density is rho, so rho L by 2. M2 को क्या लिख सकते हैं? Rho into its length, that is pi r into 2r by pi. So if you solve it, you will be getting how much? This is equal to L square is equal to 4r का square. So r is equal to L by 2. This is this. ठीक है? R का value now we know. Now we need to calculate distance of center of mass of system from the hinge. It means it is asking where is the YCM, right? So YCM we need to calculate because XCM we know it is 0. Let's calculate YCM. Now if you will do YCM, what you will write? M1, Y1. Y1 is how much? This is rod. It is what distance downward? This direction, let's say this is positive y-axis. ठीक है? क्योंकि दोनों का ही center mass downward है. No point of taking it negative. So how much distance below? This is 2r, right? So you will write here m1 into 2r plus m2 into how much is this? This is at this m1r लिखेंगे. ठीक है? m2r, sorry, m2r divided by M1 plus M2. Now let's put the values. M1 का वैल्यू आप क्या रखोगे, रो इंटू एल, 2 इंटू आर का वैल्यू क्या रखोगे बताओ, आर इज एल बाई टू, प्लस M2 का वैल्यू क्या रखने वाले हो, रो इंटू पाई आर, यानी कि पाई आर का स्क्वायर हो जाएगा, एंड आर का स्क्वायर कितना होगा, एल स्क्वायर बाई 4 डिवाइडेड बाई M1 प्लस M2, रो एल प्लस रो इंटू पाई एल बाई 2. लेट्स सॉल्व इट, यू विल गेट द आंसर. ठीक है, सो क्या होगा, जो जो कॉमन है वो बताओ मुझे पहले. रो एल इज द कॉमन, टेक दिस एज अ कॉमन, this 2 will get cancelled, so here you will get 1 plus how much, this is L by 4, right? And this is how much, रो L कॉमन लिया मैंने, 1 plus पाई बाई 2. ठीक है, एक L एक्स्ट्रा लग रहा है मुझे, कहीं कुछ तो गड़बड़ किया हमने.
मैम ऊपर वाले में आपने एल एक्स्ट्रा नहीं लिया है, लाइक रो एल स्क्वायर है.
अच्छा, वो भी एल स्क्वायर है, एल स्क्वायर ले लेती हूँ, है ना. सो दिस इज दिस. नाउ इफ यू सॉल्व इट, YCM का वैल्यू क्या दिख रहा है, थैंक यू हर्षिता, L, and this is how much, okay, this would be, there should be pi here, right? So 4 plus pi, right? 4 plus pi divided by, this is how much, 2 plus pi, and then this was by 4 by 2, so that will become how much, L by 2 finally. So it looks like this. Yes, L by 2, n plus alpha, n plus beta. N is pi basically here. N is pi, right? And alpha beta 8. That will be your answer. ठीक है, अब देखो ये क्वेश्चन था तुम्हारा YDAC से. दिस इज, दिस डायग्राम इज आल्सो गिवन इन योर NCERT टेक्स्ट बुक इफ यू रिमेम्बर. अगर तुम लोग NCERT खोलते हो तो, I mean this source, if you are setting the source, normal YDAC setup we have learned for source lying along this line. ठीक है, now it is shifted by certain distance and then question was given. Yes, Dev, I have included that question, bulb wala. Should we do that before? ठीक है, मैं करती हूँ, थोड़ा सा टाइम दो मुझे. बल्ब वाला क्वेश्चन इज देयर, बट दैट्स इजी वन. क्या दिक्कत हुआ तुम्हें वहां पे, तुम्हें सिंपल सर्किट का क्वेश्चन करना था. दिस वन, राइट? सो इस क्वेश्चन को अगर आप सॉल्व करो, व्हाट इज द क्वेश्चन गिवन, देयर इज सर्किट्स ऑन ऑल वायर्स हैव नेग्लिजिबल रेजिस्टेंस, बैटरी हैज अ कांस्टेंट इंटीग्रल रेजिस्टेंस ऑफ this value is always 8 ohm, and 2 light bulbs are given, their resistance is not given. Let's say this is R, this is R, and this is a variable resistor, right? And for a time being its value is 26 ohm. ठीक है, when this switch S is open, in that case its value is how much, 26 ohm. And when this switch S is open, this is a single loop circuit, right? Current will go like this, like this, like this, like this. So this is a single loop circuit. So जब S तुम्हारा open है, then how you will write the current? Current का value क्या लिखोगे? Battery का voltage by R equivalent. Since this is single loop circuit, all resistors are in series. तो आप लिख डालो series में. 26 plus 8, you will get 34. 34 plus R, resistance of bulb I. So in the first case, अच्छा देव, क्वेश्चन को गलत पढ़ा है ना. दिस शुड नॉट हैपन. You should be reading question more carefully. I mean you're gonna lose marks. ठीक है, so current will be this, and it is said that when you are closing the switch, glitter will remain the same, glow will remain the same. That is, if in the first case through this current was I, and in second case when you are closing the switch, current in the circuit will be different, but current through the arm of these two bulbs should be same as before, then only glow will remain same, right? So in first case current through the bulb is this, in second case you need to calculate the current. So in second case total current का value आप क्या लिखने वाले हो, V by, this is 8 for sure, let's say variable resistance is R, and bulb सॉरी आर डैश लिख लो, एंड बल्क का रेजिस्टेंस क्या हो जाएगा, आर बाई टू, बिकॉज दे आर इन पैरेलल, दिस विल बी करंट. So total current coming here is I dash in that case, and here two current will get divided into two equal parts because both are sharing the same resistance. Current going through the bulb in second case will become V by 2 into 8 plus R dash plus R by 2. ठीक है, you just need to equate these two, you will get the answer. ठीक है. यस, इस क्वेश्चन में तुम्हें करना क्या था, सिंपली यू वर रिक्वायर्ड, I mean, what's the question given? Let me read once more. The minimum thickness of the film of refractive index, this is T, which is placed in front of S1 like this. The intensity at O point becomes maximum. Find the value of 5T. 5T. So at this point, you are getting maxima. And you are asked, what is the value of 5T? अब देखो कोई भी पॉइंट पे तुम पाथ डिफरेंस कैसे निकालोगे, दिस वाज द ट्रिक ओनली. सो हाउ यू आर गोइंग टू कैलकुलेट द पाथ डिफरेंस, यहां से देखो ऐसे आ जाओ आप, सोर्स है, सोर्स से लाइट कैसे जाएगा, ऐसे जाएगा, ऐसे यहां आया, एंड देन इट विल गो हियर, अगेन फ्रॉम दिस सोर्स लाइट विल एंटर टू दिस स्लीट, अगेन इट विल गो हियर. अगर आप ध्यान से देखो, देन if you talk about the geometrical length, then these two geometrical lengths are same. Done it? But there will be path difference because there is a some what is this called, some seed capped whose thickness is T and refractive index is mu. So how much extra path length it will giving, that is what is technical term for that, optical path length. ठीक है, so how much optical path length it will give, if in air you are traveling t distance, ठीक है, then in this media having refractive index mu for the same t distance, optically light will travel mu t distance. So overall what is the difference going to get generated, mu t minus t. So that is equal to mu minus 1 into t. That is why you read the formula, because of c getting kept in the direction of light, extra path length comes, that is mu minus 1 into t. So path difference between these two is how much, I mean, अंदर जो भी दिख रहा है लाइट, उसके बीच में पार्ट डिफरेंस क्या है, म्यू माइनस 1 into t. नाउ outside the slit if you talk about, then this has traveled this much distance, this has traveled this many distance, clearly second light is traveling more distance, this much more. So total path length will be how much, it will be delta x, I mean, ध्यान से देखना, पहले लाइट ने कितना चला, सारे डिस्टेंस को आप मेजर कर लो. ठीक है, एक काम करते, लेट मी राइट थिंग्स मोर क्लियरली. तो व्हाट यू नीड टू डू इज, देखो इतना एक्स्ट्रा मैंने बताया ना, यानी कि ये वाला लेंथ और ये वाला लेंथ सेम है. लेट्स से दिस इज L1, दिस इज आल्सो L1. सो इफ आई टॉक अबाउट सेकंड लाइट, I am calling this as a second light. It is traveling how much? L2 plus delta x plus, let's say this geometrically this is L0. So plus L0. How much one light will cover? So L1 plus how much plus L0 plus how much more? How much more it will cover? बताओ. Mu minus 1 t. Now you have to calculate the path difference. अब आप इन दोनों का path difference निकाल दो. So let's say 2 is traveling more than 1. So you will, when you will subtract these two, L2 क्यों लिखा मैंने इसको? This L1 and L1 are same, right? So this is also L1. If you will subtract it, you will get what? Delta x minus mu minus 1 into t, and for maxima this should be equal to n lambda. ठीक है, if point O is given as central maxima, let's say it's saying that point O is central maxima, then n will become 0 and delta x will become equal to mu minus 1 into t. If it is any other maxima, next maxima, n will become 1. ठीक है, task is to calculate delta x. Delta x you can easily calculate क्योंकि we have already done it in simple YDAC. Let's say this angle is theta. So if this angle is theta, this value is given as d. ठीक है, how you can calculate this thing, बताओ. ओके, एक काम करो, डेल्टा एक्स बाई डी इज रिटन एज हाउ मच? साइन थीटा। डेल्टा एक्स बाई डी साइन थीटा है ना? यस। So delta x is equal to how much? D sine theta. Somehow if we know the value of sine theta, we can calculate delta x. अब देखो हम sin theta कैसे निकाल सकते हैं, इसको थोड़ा सा मैं डिलीट करती हूँ. This theta is what? This theta is angle between this vertical line and perpendicular to this line, this particular line. ठीक है? So let's talk about angle between this horizontal line and ये वाला angle. Vertical एंड परपेंडिकुलर, ये दोनों एंगल का कोई कंपैरिजन होगा? इट कैन हैपन. और अगर वो नहीं होता है तो चलो एक और अप्रोक्सीमेशन मैं बताती हूँ. सॉरी, आई हैव नॉट ड्रॉन द अनदर डायग्राम, सो आई नीड टू रिमूव थिंग्स. लेट मी ड्रॉ इट इन द नेक्स्ट स्लाइड. क्वेश्चन क्या था? यहाँ पे सोर्स है, ठीक है, यहाँ स्क्रीन था, देयर वाज टू स्लिट्स लाइक दिस हियर, राइट? एंड एक काम करो, दिस वाज द स्क्रीन. यहाँ से हमने एक लाइट लिया था and here यहाँ पे ये light हुआ. This was the extra distance it traveled. We are going to calculate this one. In what different way we can again calculate this thing? So angle को हमें check करना है, ठीक है? If this angle is theta, this is angle between perpendicular to this line, that is this line, and vertical. So किसी को कुछ दिख रहा है तो मुझे बताओ. Yes, this angle will be theta, right? क्यों थीटा हो रहा है? क्योंकि देखो, not this angle, this angle will be
90
theta.
प्लस थीटा होगा वो. यस.
हाँ, this angle will be theta, sorry. ठीक है, क्योंकि मैंने तो ऐसे ले लिया, दो लाइन के बीच का एंगल थीटा है, उनके परपेंडिकुलर्स के बीच का एंगल भी सेम होगा. सो दिस लाइन इज परपेंडिकुलर ऑन दिस लाइन एंड दिस लाइन इज परपेंडिकुलर ऑन दिस लाइन, सो एंगल बिटवीन दिस टू इज आल्सो थीटा एंड दिस डिस्टेंस इज ऑलरेडी गिवन. ठीक है, एंड tan थीटा निकाल सकते हैं क्या?
मैम इस वाले एंगल को ले लो, राइट में जो है, और राइट में जो एंगल आएगा उससे डिस्टेंस
राइट,
गिवन है ना. लाइक ये डी गिवन है नीचे वाला. हाँ,
हाँ
यहाँ पे
गिवन
जो
है,
एंगल बनेगा. नहीं मैम, नीचे इससे भी, इस
ये वाला.
इससे
नहीं,
दूसरा वाला मैम, ये कॉम्प्लीमेंट्री इससे.
दिस वन, दिस
नहीं
तो
नहीं,
90 डिग्री.
इससे नीचे वाला मैम, उससे.
आई एम नॉट गेटिंग यू एक्चुअली, आई नीड टू लुक एट
मैम ये
क्वेश्चन.
हॉरिजॉन्टल लाइन बनाओ नीचे वाले में, लास्ट वाले, सबसे नीचे वाले पॉइंट में.
यहाँ मैंने हॉरिजॉन्टल बनाया ये लाइन.
इससे भी नीचे, इससे भी नीचे.
अच्छा ठीक है, अच्छा, ओके ओके ओके, आई गॉट यू, आई गॉट यू. दिस इज दिस, राइट?
यस मैम.
सो दिस एंगल थीटा है, तो तुम्हारा ये एंगल भी थीटा होगा, है ना? यस. सो tan थीटा, दिस विल बिकम 2d अगर हमने सेम डिस्टेंस डाउन पे बनाया है तो. सो tan थीटा वी कैन राइट लाइक 2d by capital D and sin theta we can equate with tan theta. ठीक है, and if we are able to equate sin theta, we can equate because this theta will be quite small. Sin theta को आप tan theta कर दो and after that you will get the value of delta x. Put in here, you will put here, देखो एक सेकंड मेरे को क्वेश्चन पढ़ लेने दो और क्या है. So that intensity at point O becomes maximum. It's not talking about central maxima, so we will go with n equal to 1. ठीक है, put the value, you will get the value of t because we know already lambda, we know value of mu, right? Mu is given, delta x we have already calculated, so ये value तुम्हारा काफी छोटा आएगा क्योंकि this d into 2d by how much? Capital D.
मैम
You
एन
write this
जीरो भी तो
thing,
हो सकता है.
जीरो क्यों होगा?
मतलब मैक्सिमा बनाना है ना, तो जीरो भी हो सकता है.
नहीं, बट सेंट्रल मैक्सिमा की बात नहीं करा ना.
मैम बट हो तो सकता है ना जीरो पे भी.
हाँ हो सकता है, हो सकता है, डेफिनेटली हो सकता है. At point O it becomes maximum, it is said. Yes, it can be zero. लेकिन एक्चुअली क्या होता है ना, क्वेश्चंस में जब तुम रीड करोगे ना, इफ इट इज नॉर्मल मैक्सिमा then it is written as maxima. If it is central maxima, it is written as central maxima. So here it's simply normal maxima. So that is why I went with n equal to 1. अगर central करोगे तो equal हो जाएगा. From there also you will get the value of t. But here it is talking about general maxima, I guess.
मैम बट
Yeah.
इंटीजर पे तो हो ही जाएगा ना, कोई सा भी इंटीजर लो, ये तो कोई स्पेसिफाई नहीं है.
हाँ नहीं स्पेसिफाई नहीं है, इसलिए मैं बोल रही हूँ इफ नथिंग इज स्पेसिफाई वी विल गो विथ n इक्वल टू 1. व्हाई नॉट n इक्वल टू 0? बिकॉज इट्स नॉट टॉकिंग अबाउट सेंट्रल मैक्सिमा. और सेंट्रल मैक्सिमा एक्चुअली हो सकता है क्योंकि पहला जो रे है दैट हैज ट्रेवल्ड अ लिटिल मोर एंड सेकंड रे हैज आल्सो ट्रेवल्ड अ लिटिल मोर. Maybe these two can get balanced and we can get central maxima at point O. But in the question it's simply talking about maximum. That is why I took this. But don't worry, in the exam it won't confuse you. I mean, if it is simply talking about maxima or multiple choice hai, then go with putting n equal to 0 or something. But if it is single choice and central maxima is written, then only go with n equal to 0. Otherwise go with start with the 1 2 3 like that. ठीक है?
ओके मैम.
ओके, तुम लोग इस चीज को सॉल्व करना. दिस इज अ गुड कॉन्सेप्ट एक्चुअली. हाउ मेनी ऑफ यू डिड दिस क्वेश्चन? एनीवन? Okay, just give me 1 minute. I will be back. ठीक है? Yeah. So, in this question, what we need to do is, how many of you did it? Nobody? देखो क्वेश्चन को ना हमें सिंपल सोचना था. So, what is the case given here? There is a vertically hung, I mean, there is, if you hang vertically some length of a long uniform inextensible rope, the longest hanging length is this much. यानी कि if you hang this much length of this string, it will break due to its own weight. Okay, so if it is like this, then the weight acting on this will be how much? It will be your rho L naught G, and okay, so this rho L naught G and here tension T. Done it. So if tension in the string is equal to rho L naught G, it will break. Okay, it is going to break in this case. Then a L naught value is already given. Now the question is, now you cut a length of the same rope and place it straight on a smooth horizontal table with little length hanging over the edge so that it begins to slide. So it starts sliding when released. What maximum length can this piece have so that it does not break during sliding? अब देखो, for it to not break, tension should be, I mean, maximum equal to this, I mean, slightly less than this, then it won't break. So maximum, we can take it like this, rho L naught G. Now let's solve it. Second case में चले जाओ. Let's say we have taken L length of the string and some length is hanging over here. Okay, let's say X length is hanging. Done है? And then L minus X length will be here. डन है। अब आप एक काम करो, इस क्वेश्चन को थोड़ा ऐसे सोचो, देयर इज m mass here and then there is m mass here hanging like this. There will be tension here, there will be tension here, and on this mass, let's say its mass is m1, so m1g, and let's say its mass is m2, so m2. Done it? If you go on to write its equation, what equations you are going to write here? First का अगर आप लिखो, let's say it's coming down with acceleration a, then you will write here t equal to m2a, first case, and second आप क्या लिखोगे, m1g minus t is equal to m1a. This is what you are going to write. ठीक है? From here we can calculate what? t को आप m2a लिखो, so m1g minus m2a is equal to m1a. So m1g is equal to m1 plus m2 into a, and acceleration will be equal to how much? m1 by m1 plus m2g. I didn't needed to solve this much. Directly मैं लिख सकती थी m1g by m1 plus m2. Acceleration. This is the value of acceleration we are getting. If we know the value of acceleration, we can write the value of tension. So that is equal to m2 m1g by m1 plus m2. Simply put in the value of things. So if you put in the value of things here, m2 को मैं क्या लिखूं बताओ? m2 मैंने किसको लिया है? इसको लिया है. So this is L minus x rho, L minus x rho, and m1 will be how much? Into x rho into g divided by m1 plus m2. So overall length I have taken as L. So overall mass will be because of L length of the rope. So here simply I will write LG, sorry, L rho, ठीक है? So this will give us how much? रो को कैंसिल कर डालो आप, एक रो बच जाएगा, ठीक है? Whatever it is, simply write it carefully, ठीक है? जो भी constant है उसको बाहर ले लो, रो G by L, if I'm correct, and here Lx minus x square. This is what we are getting, tension. Okay, we have to maximize the tension. Then because question is what maximum length can this piece have so that it does not break during sliding. So I have taken here the length is L, x length is hanging like this. So in order to maximize this tension, what we need to do, we need to differentiate it with respect to x. ठीक है? So अगर आप इसको solve करोगे, dt by dx को अगर आप 0 करोगे, what value we are going to get? L minus 2x. L minus 2x is equal to 0. So x is equal to L by. ठीक है? So question था क्या? What maximum length can this piece have? Which piece? Which piece is the piece that is hanging, right? Yes, little length hanging over the edge of table. So x का हमने tension को maximum किया, x का value क्या आ रहा है? L by 2. So L should be what? It should be L by 2. And अगर तुम्हारा L कितना आया? L we are getting as L by 2. What will be the value of I mean, how we will calculate L? Can anybody see it here? Okay, how we will get answer after this? हमने maximum hanging length निकाल लिया, ठीक है? That is your L by 2. If L by 2 is hanging, then it won't break. Now we have to calculate the value of what maximum length can this piece have. So we need to calculate L ka value in terms of L naught, whatever it is given, right? So do one thing, maximum tension is given, right? That is rho L naught G. And here tension value is how much? This much. यहाँ से हम maximum tension निकाल सकते हैं, right? So T maximum आप निकाल लो. T maximum का value कितना होगा? Rho G by L. And this is how much? Lx minus x square. So Lx का कहने का मतलब L square by 2 minus x square था ना? So that is your L square by 4. So this is 2. So this is equal to how much? Rho G by L. And this will be how much? L square by 4 something. So T max तुम्हारा कितना दिख रहा है? Rho G L by 4. ठीक है? and the maximum tension can be equal to how much? Rho L naught G. So this maximum tension can be equated to rho L naught G will be equal to rho G L by 4. If you solve it, so length here we can take how much? 4 L naught. So total length will be 4 L naught such that hanging part is of length how much? L by 2 for maximum tension case to occur. So that way you can calculate it. Okay? Any doubt, anybody? किसी को कोई doubt है इस question में? You can simply make it a 2-mass system and then you can solve it like this. चलो किसी को doubt हो तो जरूर पूछना. Now this question I'm not going to solve because you can solve it very easily. I mean, question was given as what? There is a rod of mass M and length L. This is fixed, right? This is not going to move. So AB is fixed. There is a point mass getting released from C, shown in the figure. Point mass start moving towards rod when set free. So it start moving in this direction. The question was what the speed of point mass at a distance L by 2 from the end P is given, and that is given as this. Then we were supposed to calculate x plus y. If you look at the this velocity का expression, what is given
हम
here?
वो जो small l लिखा हुआ है वो ln है ना?
हाँ यार, हाँ, correct. They made a mistake here. Correct. ln है ये. Paper should be flawless. It's really problem. Yeah, that's ln. Correct. So, what things we need to look here? जैसे velocity को जैसे ही तुमने देखा ना, here gm is written. So basically, this mass, small mass m is moving under the influence of gravitational force of this rod, right? So at C point, it has certain. It is moving from C to this point. Let's say D. So how its velocity is going to change? Work is getting done by which thing? Potential. So work done per unit mass will be equal to what? Change in potential you will write. So change in gravitational potential you do here. Okay? Simply what you have to do, you have to calculate potential at C, gravitational potential at C, and then gravitational potential at D. We can easily calculate it क्योंकि हमारे पास देखो क्या है, एक रॉड है, ठीक है, ये है तुम्हारा एंड, ये A, ये है B, and then this is point C. So if you have to calculate gravitational potential at point C, this is the simplest system. This is rod, right? Let's say because of this dx length at a distance x, we are going to calculate potential at point C. So you will be writing minus g dm by x, right? So you will write minus g dm का value क्या लिख सकते हो? Lambda dx by x. This you will integrate from for calculating total potential at C because of rod. X will vary from where to where? It will vary from this point, that is that we can take as 0 to 12, right? No, I mean this is
L to 12, ma'am. L to 12.
yes. This end is at a distance how much? This end is at a distance of 12 and this end is at a distance of L. So it will vary from 12 to L. Similarly, then you will get potential at point C, and if you have to calculate potential at point B, you will be doing what? Minus g lambda, again dx by x, limit will only change. So at this point you are calculating this distance is how much? 3L by 2, and this is how much? L by 2. So you will be changing it from this to this and you will get potential at point B, and thus you will get the answer. Okay? So this is how you were supposed to solve. Work done को अब आप लिख सकते हो work done by all, I mean, and this will be equal to change in kinetic energy, right? So that is equal to half mv square because initial kinetic energy is 0. So you can simply solve it like this. This question we have already done. You will be able to do this. हाँ, ये क्वेश्चन बहुत इंटरेस्टिंग था. इसको अगर तुम लोग एनसीईआरटी के एक क्वेश्चन के हेल्प से तुम लोग इसको कर सकते थे. विच क्वेश्चन? इफ यू रिमेम्बर, अगर तुम लोगों ने एनसीईआरटी सॉल्व किया है तो देयर इज अ क्वेश्चन लाइक देयर इज अ स्क्वायर शेप थिंग एंड देन एट इट्स सेंटर at a distance of a by 2 there is a charge kept q. And then we were asked what will be the flux through this square surface. पूछा था ना? So basically, this is at a distance q by 2, not in the same plane of this square surface. This is at a perpendicular distance a by 2 from the seat, right? And in the question, what is given? देखो इस question को ना तुम्हें ध्यान से पहले plot करना था. So there is a charge q kept at this point, and consider a triangular plane surface whose coordinates of vertices are this, this, this. अब देखो इस क्वेश्चन को हमने कैसे सॉल्व किया था? Since at its center, I mean at a perpendicular distance a by 2 from the center q charge is kept. If you bring another 5 seats like this and you convert it into a cube, if you convert it into a cube such that this was the original seat, this was the original seat, and charge was kept at its a by 2 distance like this. If we bring more 5 seats, this will get converted into a closed cube. And we know that flux enclosed by a closed surface is equal to q enclosed by epsilon naught. So through 6 surfaces, it is this. So for one surface, it will become q by 6 epsilon naught. हमने ऐसा किया था, ठीक है? Similarly, here we can do. अब देखो इसको डायग्राम बना दो चुपचाप. If you keep the diagram here, A2A0 पे एक point है, and 2 points are at the same x distance, right? 3a by 2 and 3a by 2. So let's take the 2 points like this, and then this is the third point, A2A. ठीक है? So it will be, I mean, okay, this is, एक second. So this is your A, 3a by 2, 2a, 3a by 2, 5a by 2. So why I'm getting confused? Vertices कैसे बनाऊं? We can draw it like this, right? If this is this, this is this, it will look like this. ठीक है? क्योंकि right angle triangle तो होने वाला है, क्योंकि दो का x सेम दिख रहा है मुझे. 3a by 2 है, 3a by 2 है, ठीक है? And 2 का तुम्हें y भी सेम है, 2a and 2a. So definitely this, if this has a value of, let's say a, this has a value of how much? 3a by 2, and this is your 2a, and then this is your what? 5a by 2. So this is this, right? The charge is placed where? A, 2a, a by 2. So charge is placed somewhere perpendicular distance from this point. ये वाला point, P point. ठीक है? ऐसे रखा हुआ है. कहाँ रखा हुआ है? Not in this plane. At a distance a by 2 from this point P. In the plane, in which plane? XYZ plane. It's not kept in the XY plane basically. डन है? अब देखो इसको कन्वर्ट कैसे कर सकते हैं. अगर तुम लोग ध्यान से सोचो, सॉरी आई कुडंट टेक अ स्पेस. ठीक है, क्या करूं? लेट मी डिलीट द this thing. Okay, I will do one thing. What we have to do, we have to keep this charge at a symmetry. Symmetry लाने के लिए देखो क्या कर सकते हैं. यहाँ पे ये है, ये हमारा ओरिजिनल है, ये हमारा क्या है? ओरिजिनल है. अब मैं जो भी बनाऊंगी डॉट में बनाऊंगी. So what I did is I kept one more surface here, and if I use this thing, if I use this as one surface and then bring 5 surfaces, then charge is here, remember, here at a perpendicular distance. Then charge won't come at the center, right? So it won't be symmetrical. We have to bring
चार्ज
that
तो
at
वर्टाइसिस पे होगा ना,
क्या?
लाइक लेफ्ट वाले वर्टाइसिस पे होगा ना चार्ज,
नहीं, वर्टाइसिस पे कैसे होगा?
मतलब
A
उसका
to
थोड़ा
A
सा
by,
ऊपर होगा लाइक. हाँ,
okay, this is
बट मैम
A.
लेफ्ट वाले से कोऑर्डिनेट उसके दो मैच करेंगे ना.
हाँ, ये A to A होगा ना. So on this somewhere here, right? Okay, okay, okay. डन है, डन है. सो मैंने यहाँ लिख दिया था ए. हाँ, ये होगा. यहाँ पे आप क्यू लिखो, ठीक है? सो इट इज हियर. डन है, सॉरी, या यू आर राइट. ठीक है, सो चार्ज को यहाँ रख दो. अब यहाँ है, मैंने एक लिया ऐसे डॉटेड सरफेस. If I'm bringing such 5 surfaces like this whole square, then will charge be at the geometrical center of this whole geometry? No. नहीं होगा क्योंकि चार्ज इज एट द कॉर्नर हियर। और तुम अगर अभी क्यूब बना देते हो टेकिंग दिस सरफेस एज द बेस, then your charge will be where? If you are able to see, it is here, right? It is here, right? So we have to make charge somewhere here. डन है? क्या कर सकते हैं देखो, इसको सिंपल है, मैंने तो ज्योमेट्री से ही इसको कर दिया। सो ऐसे कर लो, टेक वन मोर सरफेस, टेक वन मोर सरफेस हियर, टेक वन मोर सरफेस हियर। नाउ इट इज एट द सेंटर, राइट?
यस
ठीक है।
मैम।
अब क्या करो, टेकिंग दिस बिग स्क्वायर एज द surface, take more such 5 surfaces, this q will be at center, total flux will be q by epsilon naught, and flux through this whole surface, this big surface, will be how much? q by 6 epsilon naught. Now talk about our portion, हमारा portion था ये छोटा वाला, this is part, how much part of this whole it is?
1/8.
1 by 8. So it will become 1 by 8 into q by 6 epsilon. So answer should be q by 48 epsilon naught. ठीक है? So with the help of symmetry, we could have done it. And we should have done it this way only. Because if anything else we use, I mean, it will become very difficult. ठीक है? देखो ये क्वेश्चन एक बहुत ही कॉमन क्वेश्चन होता है, ये बहुत बार in every test you will be getting. I mean, if you are really attending tests, then not every means every JEE advanced test series की बात कर रही हूँ, not single test. So consider a network shown in the figure. Switch S is open. When switch S is open, then condition is like this: the amount of charge flow through earth wire after closing the switch. So when you are closing the switch, it is asking how much charge is flown from earth to capacitor or anywhere. ठीक है? So before this switch is open, let's say initially it is open, right? So initially when it is open, you can clearly see these two capacitors are in what? They are in series. So 6C and 3C in series will become how much? 2C. 6 into 3 by 9. So this is 2C. And this is also how much? 2C. So 2C and 2C, they are in parallel. Across this 2C, potential difference is V. Across this 2C, potential difference is V. So overall, if you talk about charge, then in the above arm, if you talk about charge, this across this potential difference is V. This whole is how much? If you just simply replace it with single capacitor, this is 2C. And potential difference is V. So charge is 2CV. And when you will break 2CV into these two individual capacitors, they are in series. So charge again, it will stay like 2CV. Okay? Because these two series combinations are equal to this. It means whatever charge is on this capacitor will be same as charge on this individual capacitor. They are in series. So initial charge on this is 2CV, and on this also it will be how much? On each capacitor? 2CV. So initially I've written here charge on this capacitor is 2CV. What will be the charge finally when you are closing the switch? अब आप switch को close कर दो. What happened? This point is earthed. This point is also earthed, right? So it seems like they are shunted like this. They will share
मैम
the
ऊपर
same
वाला तो पहले ही
potential.
अर्थ था ना।
क्या?
मैम ऊपर वाला तो ऑलरेडी अर्थ था ना, नीचे ही तो स्विच है।
हाँ, पहले से अर्थ था, हाँ।
स्विच तो
So
सिर्फ
it
नीचे
has
है ना।
potential 0. क्या?
नहीं आपने
Yes,
कनेक्ट
tell
कर
me.
दिया ना, वो कनेक्ट कैसे हो गए वो?
हाँ, मैंने डायरेक्ट कर दिया, मुझे लगा तुम लोग समझ रहे हो। एनीवे, अर्थ किया, देखो यहाँ पे अर्थ किया ना सेकंड केस में, सो इसका पोटेंशियल भी क्या हो गया? 0 हुआ ना?
यस मैम।
सो दिस इज 0, दिस इज 0, सेम पोटेंशियल, इट मीन दे आर शंटेड, राइट?
यस मैम।
यस, सो दे आर शंटेड लाइक दिस। अब आप देखो ये 6C और ये 3C, दे आर इन पैरेलल. 6 into 3 in parallel will get added like series, right? So 9C, this is also 9C. ठीक है? And if you want to, and this 9C are in series, when you will bring them in parallel, they will become how much? 9C by 2. So whole equivalent is how much? 9c by 2. Potential difference is V. So total charge, if you talk about, एक सेकेंड, चार्ज डिस्ट्रीब्यूशन करना है हमें. लेट्स डू इट मोर इजी वे. ठीक है. सो टोटल इक्विवेलेंट मुझे पता है. एक काम करते हैं, इसको हमने संट किया ना, दिस इज 9, दिस इज 9. टोटल पोटेंशियल इज V. सो दिस विल गेट ड्रॉप ऑफ V by 2 and this will get a drop of V by 2. Agree?
मैम बट राइट साइड तो जीरो होगा ना पोटेंशियल.
डिफरेंस की बात कर रही हूँ.
राइट मोस्ट में भी जीरो होगा और लेफ्ट में भी, तो वो हट जाएंगे ना.
दो जगह जीरो नहीं मान सकते शायद.
Which one you are saying zero?
मैम ये जो लाइक बैटरी के इधर एक तरफ V मानते हैं, एक तरफ जीरो.
नो, जीरो जीरो हम ऐसे मान लेते हैं. हम कहते हैं ऐसा कि इसका पोटेंशियल क्या है. आई मीन इट हैज सम नेगेटिव पोटेंशियल, इट हैज सम पॉजिटिव पोटेंशियल, सच दैट डिफरेंस इज V, right? So if you are considering this as a V, then you will take this as a zero, and such that difference is V minus 0 V. Done it? It doesn't mean absolute value of potential of this plate is zero.
ओके.
ठीक है. सो इट इज दिस. अब देखा तुमने, ये सनटेक था, इसके अक्रॉस दिस इज 9 कूलम, दिस इज सॉरी 9c, दिस इज आल्सो 9c. सो अक्रॉस इट पोटेंशियल इज V by 2, अक्रॉस इट हाफ ऑफ डिवाइड होगा. सो चार्ज इफ यू हैव टू कैलकुलेट ऑन दिस, चार्ज विल बी 6c into V by 2. Here it will be 3cV by 2. So charge on this is 3cV by 2, on this it is 6cV by 2. So finally charge I have written here 3cV by 2 and 6cV by 2. अब देखो चार्ज फ्लो कितना किया, कैसे निकालोगे. यू जस्ट टॉक अबाउट इनिशियल स्टेट. इनिशियली if you talk here, this is the capacitor, one capacitor I'm taking off 3C, and this is the another capacitor of which one, एक second, of the 6C. ठीक है. On this there is a negative charge, so here I'm putting negative charge. And here how much charge is there? Plus charge. In the first case, it is not connected to earth. It has a charge of 2cV, and it has a charge of how much? Initially also 2cV. Okay. So this is charge on these two plates initially. After connection is made, if you talk about the same two plates, then charges are looking like what? On this plate, there is a negative charge of how much? 3cV by 2. And on this plate, there is a positive charge of how much? 3cV by 2. So just talk about, just see how the charges have changed. So initially it was minus 2cV, and now it is minus 3cV by 2. So its negativity has decreased, right? How it happened? This plate must have received how much charge? Here, if you check half CV charge, CV by 2 charge it must have received from the earth. This earth provided to this plate CV by 2 charge. Okay? Then only it became minus 2 CV plus CV by 2 if you will do. Then you will get minus 3 CV by 2, which is the final charge on the negative plate. What does it mean? It has a simple meaning. CV by 2 amount of charge traveled from earth to this plate of 3C, right? Similarly, if you check here, this plate was initially having plus 2cV charge. Now it is having 3cV by 2 charge plus. Its positivity decreased. How it happened? It means decrease हुआ ना? नहीं. Yes. So how much charge must have traveled in this case? If you talk about, so positive charge traveled, right? How much? और नेगेटिव चार्ज ट्रेवल फ्रॉम हियर टू हियर, हाउ मच? CV by 2. ठीक है. CV by 2 एक बार कैलकुलेट कर लो यार, जो भी है. यहाँ पे 3cV था. सॉरी आई डिड द मिस्टेक. क्या मिस्टेक किया मैंने? मिस्टेक ये किया कि मैंने इस पे भी 3cV by 2 लिख दिया. सॉरी यार, ये 3cV by 2 नहीं है ना. दिस इज हाउ मच? 6cV by 2. सॉरी. So this is your how much? 3cV. So initially it was 2cV. Now it is 3cV. Means earth gave it how much charge? Extra CV charge. So this plate received CV by 2. This plate received CV charge. Total how much charge traveled? CV plus CV by 2. That is your 3cV by 2. ठीक है. So तुमसे क्वेश्चन यही पूछा था, when you are switching on this, when you are connecting the switch, what will be the amount of charge flowing? So तुम्हें ये देखना चाहिए था कि इस स्विच से और इस अर्थ से directly which plates are connected. So directly connected plates are which plates? Are 3 coulomb 3C का right plate and 6C ka left plate. This is connected to earth directly. So initially you need to look at how much charge is here and how much charge is here, and finally you need to look at how much charge is here, how much charge is here. Whatever difference is occurring because of charge getting flown from earth to the plate, so that you were supposed to answer in this question. ठीक है?
मैम
Done? हाँ बोलो.
पिछले वाले क्वेश्चन में डायरेक्ट नहीं कर सकते थे मतलब
इसमें
इनिशियल फाइनल चार्ज निकाल लिया और जब बीच में शंट होने के बाद फाइनल चार्ज निकाल के दोनों का डिफरेंस ले लो।
which question? Sorry, your voice is, I mean, it's
यही
so.
क्वेश्चन
Sorry,
कैपेसिटर मैम, कैपेसिटर वाले क्वेश्चन।
this question, right? What you're saying?
मैम मैं कह रहा हूँ कि ऐसा नहीं कर सकते कि मतलब इनिशियल फाइनल चार्ज निकाल लेते हैं और जब इस बीच में शंट हो जाएगा, कनेक्ट हो जाएगा, फिर फाइनल चार्ज तब निकाल लो और फिर दोनों को माइनस करके फिर।
नहीं, अगर तुमने Q टोटल निकाला ना, इनिशियल और फाइनल, they will be mistake because this battery is also providing charge, right? But if you have to only talk about charge flowing through the switch here, then you just have to fix your discussion around this plate and this plate, because if you see this plate and this plate, they are not directly connected to the battery, right? They are directly connected to the earth if switch S is closed. Done है? So if you हाँ, अगर तुमने Q टोटल निकाल के कर दिया तो गलती हो रही है, क्योंकि वो बैटरी के चार्ज को यू आर ऑल्सो इंक्लूडिंग एंड डिस्कसिंग, सो दैट यू कैन नॉट डू. ओके, अगेन दिस क्वेश्चन इज नॉट डिफिकल्ट, यू विल बी डूइंग इट. चलो तुम लोग कर लेना. यहाँ पे भी तुम्हें एवरीडे ही लिखना था, नथिंग मोर. सो अगर किसी को डाउट हो, यू कैन लेट मी नो, आई मीन थ्रू मैसेजेस एंड ऑल. आई कैन हेल्प यू विथ अदर क्वेश्चंस. किसी ने सर्किट का क्वेश्चन किया था क्या? ये वाला क्वेश्चन किसी ने किया था? एक बार तुम लोग ट्राई करना इसको.
ट्राई किया था लेकिन सिमेट्रिक से हो नहीं रहा था.
अच्छा, तो मुझे भेजना एक बार.
यस मैम.
ठीक है, आई वॉन्ट यू पीपल टू डू दिस. देखो तुम लोगों ने जितना भी मॉक टेस्ट में जितने भी सर्किट के क्वेश्चंस आए हैं ना, आई विल टेल यू टू प्रैक्टिस ऑल दोस क्वेश्चंस, सो डू प्रैक्टिस. चलो ठीक है एवरीवन, किसी के पास अगर डाउट हो तो मुझे सेंड करना, आई विल बी हेल्पिंग यू विद दोस डाउट्स. दिस क्वेश्चन यू मस्ट बी डूइंग, सिंपली फॉर्मूला बेस्ड क्वेश्चन है, प्योर फॉर्मूला बेस्ड क्वेश्चन है, ठीक है? सो यू शुड बी डूइंग इट. चलो ठीक है.
थैंक यू मैम.
Everyone, yeah, thank you so much. Take care of yourself and keep doing more number of questions. Bye everyone, take care.